Hey, this is Miss Womack, and this is Absolute Value Functions. I want to send out a special thank you to Miss Ayler for providing the PowerPoint for this video. So what does absolute value mean? Well, we see the function f of x is equal to the absolute value of x. That's what our form looks like. So let's sketch the graph and find out. We see here that the absolute value of -1 is equal to 1. Why? Because absolute value is distance from 0. Therefore, we can't walk -1 miles. So it's going to be +1. 0, when we find the absolute value of 0, is 0, and 1 is 1. When we sketch it, it's going to look something like this, a V shape, and it's going to open up. To the left of x equals 0, the line is y equals -x. To the right of x equals 0, the line is y equals x. Notice that the graph is symmetric about the y-axis. Remember coordinate algebra? Well, here it is again, an absolute value function. Every point in quadrant 1, that is, anything with a positive x and a positive y on the graph, has a matching point in the second quadrant. That is, a corresponding -x and y. Here is the vertex form for an equation. Now the vertex can be found by taking the opposite of h. Note here that the sign says -h. You don't see the minus here, so there will be a sign change. Once that is found, you have not only found the vertex with the h and the k, but you've also, using the h, you find the line of symmetry, where x is equal to h. Remember, it's going to be V-shaped. If a is greater than 0, then the graph is going to open down. That means it's going to be a negative. Again, if a is negative, it's going to open down. If a is greater than 0, then it's going to open up, and it's going to be positive. The graph is also going to get wider if the absolute value of a is less than 1, which means it's going to be a fraction like 1/2 or 2/3. If you see that, it's going to open up. It's going to be wider like this. And the graph is going to become narrower if the absolute value of a is greater than 1. Let's say 3, or even -3 for that matter. Just remember that -3 would be kind of open and down, right? Last thing, a is the slope to the right of the vertex, and -a is the slope to the left of the vertex. To graph y equals a, absolute value of x minus h plus k, first we're going to plot the vertex. Then we're going to set what's in the absolute value symbols to 0 and solve for x. And it gives you the x-coordinate. If the vertex of the vertex and the y-coordinate, well, that's going to be your k. We're going to use the slope that we find, once again, right here, to plot the other point to the right of the vertex, identify our line of symmetry and that third point, and complete our graph. Let's try an example. First, let's locate the vertex. The vertex can be found using the h, which is right here. We're going to change that sign. It's going to be -2, 3. Plot the point. We're going to apply the slope. Did you see? Did you find the slope? It's right here. Maybe you didn't recognize that that was -1 in that imaginary 1. Again, we're going to drop 1, go down 1, and to the right 1. And that is going to identify our second point. Plot our point there. Use the line of symmetry again. Where is it? It's at -2. It was the h that we found. Plot that line. X is -2. Plot your third point, which reflects across that line of symmetry. And then complete your graph. Here we have a student that tried it. How do you think they did? Well, let's check. Did they change the sign and identify the vertex correctly? They did. That is 1, 1. What about the slope? Did they do the second step correctly? The slope is definitely -1, like the other example we just saw. They went down 1 to the right 1 and plotted it. Looking good. That is definitely our line of symmetry, and they definitely plotted. Yes, it's looking good. 100. Good job, kid. All right. The vertex, let's now look at how do we write an equation from a graph. We're looking at it in reverse. So our vertex is located at 0, -3. We're going to use this form, same form we've been talking about. We're going to substitute the x of the vertex, which is now our h right here, and the y is going to end up becoming, the -3 will become a -3. Now, to find a, or the slope, we're going to substitute the coordinate of a point. And that point we see, I can see one on the graph right here, right now. It's 2, 1. And we're going to try to solve it. Now, what does that mean? Well, we're taking the 2 and substituting it in for the x. Then we're going to take the 1 from this point right over here and substitute that in for the y. Now we're going to solve. A, absolute value, we're going to solve what's inside these parentheses first. 2 minus 0 is 2. Now, this is a tricky part. This is a multiplication or a product, the whole thing. Now, our form in mathematics, we typically lead out with the coefficient. So I'm going to write 2a instead of a2. Bring down the elements that we have not used in our equation. Make the least amount of moves possible. I can use the inverse operation and move things around all day long, but I want to make the least amount of moves possible. So I'm going to add 3 to both sides. 0 the 3's out. I have 4 on this side. Bring down my 2a, divide by 2 on both sides, and I see that my a is actually equal to 2. Now, if you didn't want to do that, and you have a pretty good-looking graph, you can actually just count the slope. Yeah, and I can find any point on this graph. And in this case, I see that we can start there if we want to. And I rise up 2 and run 1. That's also another way to do it. And I see that the slope A is actually 2 over 1, which is 2. So that might be easier for you. Next, remember that A is positive if the graph goes up and A is negative if the graph goes down. So this one was positive. And we see here's our equation. Y is equal to 2, absolute value of x minus 3. So let's write the equation for this one. Pause the video. So, how'd you do? Did you have trouble with the 3 or identifying the vertex? A lot of people do. Always remember that the 3 is going to go in the coordinate or in the ordered pair in the position of, you know this is x and you know this is y, the position of the movement that's happening. Okay, it's 0. Is it moving left or right? No, it's moving just up on that y-axis. So that's the 3 on the y, therefore the 0 must be there. There's our vertex. And you probably didn't do all that math I showed you. Just rose up 1 and ran 2. Good luck on your assignment today, Miss Womack.